Okay, it is 5 o'clock here in Munich, and I would like to welcome everyone to today's webinar. First of all, I would like to introduce myself really quick. My name is Gregor Wilhaug. I am the product line manager for the Trimble GeoSpatial product or software product portfolio. And with me today is Christian Weise, who will present the new features, new functionalities in eCognition 8.7. Christian has a background in geoinformatics. He joined the eCognition team back around 2005. Went through various roles in training support and with a focus on consulting or professional services. In that role, he also managed large consulting projects such as for the German Armed Forces. And recently, he joined the product management group and now holds the role of product manager for eCognition. Before I hand over to Christian, I would like to give you a brief overview of the Trimble GeoSpatial workflow, provide you some insight on sort of how Trimble GeoSpatial is at the moment set up. So with the GeoSpatial division within Trimble, we have essentially all different products and both hardware and software to cover the entire geospatial data flow or data processing flow. So on the hardware side, we have both land and aerial platforms for imagery and point cloud acquisition. So on the land side, we have the Trimble MX8 product, which allows you to create point clouds on a mobile platform. We have aerial cameras as well as aerial laser scanning and imaging sensors and flight management environments. On the software side, we have data processing environments or tools for the land mobile part with Trident Analyst. And we also have the Info software suite for photogrammetry and orthophoto production, as well as point cloud processing. And finally, we have the eCognition software environment, which is really focusing in on the data analysis and feature extraction component of the geospatial workflow. So with this entire product portfolio, let's say, we're well set up to transform geospatial data into geospatial intelligence. With that, I would like to hand over to Christian Weise, who will now present new functionality and features in eCognition 8.7.
Okay, let's get started. My name is Christian Weise, and as you know now, I'm the eCognition product manager. Today, I want to give you a presentation about our new eCognition version 8.7. I will start my talk with a short introduction to our software suite in general, and followed by the two main topics of this presentation, the eCognition 8.7 highlights and some live demonstration of new features and algorithms. Before I will close my talk, you can ask questions, of course. The eCognition software suite is an image analysis platform. The first component of this suite is the eCognition developer. It is a development environment for object-based image analysis. The eCognition developer offers all the necessary tools to create, combine, modify, and calibrate rule sets or applications. For instance, the process tree window in which you can develop tool sets. With the eCognition developer, it is also possible to process your data, to execute and monitor your analysis, and to review and edit the results. The second component of our software suite is the eCognition Architect. It provides an easy-to-use front end for non-technical professionals to use our eCognition technology. The main function of the architect is to combine, modify, and calibrate existing applications which are created in the eCognition developer. It is also possible in the eCognition architect to process your data, to execute and monitor the analysis, and to review and edit the results. The last component of our software suite is the eCognition server. It provides a processing environment for batch execution of image analysis jobs. Architect or developer users can submit projects which contains the data to the eCognition server, and the server will process the given data in a batch mode and gives the results back to the local client's software components like the architect or developer. The server installation comes also with helpful tools to administrate the scalable grid architecture of the eCognition server and to monitor the analysis jobs. The three eCognition software components can be used standalone or in combination. A typical production combination is that an image analysis specialist creates a solution in the eCognition developer environment, and some professional colleagues can calibrate the solution in the eCognition architect environment to solve an image analysis task and submit the calibrated solution to the eCognition server, and the eCognition server will process the data and gives the results back to the architect users. In the architect environment, it is then possible to review the results and edit the results. Now I want to switch to the new eCognition version 8.7. We released this version for 2 weeks, and all users with a valid maintenance contract can download, install, and use this software now. This slide gives you a short introduction to the highlights of eCognition. The new object-based point cloud analysis capabilities make it now possible to analyze raster, vector, and point cloud data in combination. With the new machine learning algorithm, it is now possible to tackle complex data analysis problems, and the improved development environment make it possible to create flexible rule sets. Now, some more information about the new capabilities to use point cloud data in eCognition 8.7. eCognition provides now object-based point cloud feature. These features give us more information to the structure of an object than 2D elevation raster layers. They describe the 3D structure of in 2D segments. We call this selective 3D. A rasterization of the point cloud file can be skipped now. And the trick is that the 3D attributes will be directly calculated from the XYZ information of the given point cloud file. eCognition 8.7, it is also possible to load and export point cloud files now. The new export supports furthermore the classification or reclassification of the given points. Bottom line, with the point cloud features and the point cloud import and export functionality, it is now possible to combine raster images and point cloud information in one object-based analysis workflow. Let's move now to the new machine learning techniques. The best approach for large-scale land cover mapping tasks are often statistical classification methods. eCognition 8.7 offers now some state-of-the-art machine learning algorithms like CART and support vector machines. With these supervised classification methods, it is now possible to tackle complex problems, for instance, to classify hyperspectral data. Bottom line, eCognition offers now an end-to-end workflow for sample-based statistical classification using CART and support vector machines. And it combines statistical classification approaches with the existing object-based image analysis technique. Another aspect of the new version is the improved development environment. The new array concept in eCognition gives developer the possibility to create flexible rule sets, which are responsible to different input information, like unknown class names, unknown layer names, etc. Furthermore, arrays allows a better rule set maintainability. eCognition 8.7 contains also an improved vector support. It is now possible to generate classes and samples based on the shapefile information. In the past, it was necessary to create every class manually for instance. Now you can do this with the process automatically. This feature completes the statistical classification workflow finally. Summing up, our team creates and improved many new algorithms and features for the new version, and more than 25 major bugs are fixed in eCognition 8.7. For detailed information, please take a look into the release notes and in our community. So, I'm now prepared to demonstrate some of the highlights live, so I have to switch to the eCognition developer. Hopefully you can see the eCognition developer now. On the left side, there is an example of the Trimble Harrier dataset, which contains an RGB image data and a LiDAR point cloud file, which you can see here. The spatial resolution of the images is 0.1 meter. The first step of this example is to create object based on the RGB images, and I want to do this with the multi-resolution segmentation based on the RGB images. On this example, or this live demonstration, I want to show you now the new point cloud features to classify elevated vegetation based on the given data. One of the new algorithms in the eCognition 8.7 is the so-called pre-calculating LiDAR file matrix algorithms. With this process, we can cache the new point cloud feature into the project to improve the performance to use these new features. I want to execute this now, and it takes some seconds, and then we can take a look to a fast look to the new features. The new features are object features. You can find it here under point cloud features, and this features gives us structural information about the given point cloud. For instance, based on the elevation, we want to see now the standard deviation of all returns. And if I double click on it, you can see it here. The next step on this example is to use the point cloud information to classify the vegetation. To do this, we want to use a customized feature which divided the number of last returns by the number of all returns. Because vegetation objects or vegetation areas has multiple returns, and all objects with values greater than 1 has multiple returns, and they can be used as seeds for vegetation classification. I want to show this now. Here, it's very simple, and we use this feature now to assign all objects with has values greater than 1.1 to elevated object. That means we classified now vegetation only based on the 3D information of the point cloud. In the next step, we can use now the spectral information, for instance the ratio green, to improve the given classification, maybe to remove some too dark or too bright objects and grow the values into similar neighbors, the objects. Okay, from this point we create objects based on the raster layer and classify the vegetation based on the multiple returns information of the point cloud. Now it is also possible with the new point cloud features to separate the vegetation in different height classes. To do this, we use also the new point cloud features. In this case, a customized algorithm, a customized feature. We subtract the elevation minimum of last returns from the elevation maximum of the first returns. In this case, maybe here for this object, you see the elevation is 9 centimeter. And based on this feature, this is very simple to classify the given vegetation objects into different height classes, which you can see here in the class hierarchy window. Just a moment. in one step. And based on these new features, you can see the vegetation is classified in different height classes. For instance, this tree here has an elevation greater than 25 meters. Okay, bottom line, we use the raster layer for object creation and the 3D structural information from the point cloud, directly from the point cloud. We use this information to find vegetation and to separate the vegetation into different height classes. Now I want to switch to the next demonstration. It's the new machine learning techniques in eCognition 8.7. This example covers the main step of a statistical classification approach, in this case the card classification. First, the segmentation. Here we create objects based on all given bands of this quickbird scene, and then followed by the creation of samples. In the past, it was necessary to create all the classes manually. With the new parameter of the algorithm assign class by thematic layer, we can create classes now automatically based on the shapefile attribute column here called class name. What you can see here in the class hierarchy window, there are no classes available. If I execute this now, the algorithm checks the column of the given shapefiles and creates the classes based on the string attributes. And the only thing what we have to do now is to change the color of the classes, maybe here for the build-up class, to gray, and, oh, come on, and for this class to dark green. The other things looks like good. Now there are new classes and samples available, and we have only changed the color. Okay, that's something what we did. One of the most important steps of such a supervised classification is to train the classifier with the given samples. To do this, we are using now the new classifier cards, the new card classifier, and using the operation train based on the given samples to train the card classifier. And under the type of the classifier, we are able to select the method to classify or to train the classification. After this step, or as soon as we execute this process, the classifier will be trained, and now we can apply the classifier with the same new algorithm with the operation apply. If I want to do this now, we can classify the whole image based on the trained classification method. One of the new things with the card classification is that we can also create a rule set based on the given of the trained card classifier. To do this, we can query the trained classification to generate a complete new rule set which classified the image with the calibrated or generated thresholds. To see that it works, we can execute the segmentation again and run the classification based on the new card tree generated with the typical eCognition processes. With such a rule set, we are able now to save this and run it on other quickbird images to classify the whole scene, the whole world with the trained and generated card tree, this decision tree. Okay. For all new features and algorithms are examples available in our community. I want to switch now to the community, just a moment. If you want to learn how you can use maybe the new ARI concept, please download an example from the RuleSet Exchange or search with the tag to it, and then you can find examples on how you can use this new functionality in eCognition. The eCognition community provides an integrated environment for collaboration and knowledge transfer. The wiki is a collection of the eCognition-related articles like rule set tips and tricks, strategies and algorithms. Under discussion, you can ask questions and get answers. And the file exchange or the rule set exchange shares any type of eCognition code, rule sets, application or plugins. Now, what I want to do or show you also is the availability of the trial version of eCognition 8.7. It's available until now, and for all new customers on the phone, they can download the software and has the full functionality without any kind of export. That's the main information about the trial version of our version. Okay, I hope you have some questions.
So with that, I would initiate the Q&A session. I can see that we already have a number of questions coming in. I just have to maximize my panel here so I can actually see the questions. So again, to enter a question, please use the Q&A environment. Type your question, and now I will sort through the questions. We have plenty of time for questions, but we also reserved quite a bit of time because we have more than 200 participants in today's webinar, so I think there's going to be a lively discussion. So the first question that I can see is what type of card algorithm actually is offered in the new machine learning option, and Christian looks at me, so since I've been involved in the development of that one, we actually used the underlying library which is used in that card implementation is the Open Computer Vision library. So that has sort of the card implementation, and it's an open source library, so you can look up all the details on this one. Another question that probably Christian can answer is whether it will be possible to get a copy of the sample data and rule set.
Yes, of course. All the sample data and the rule sets are available in the community. It's very simple. Please use the search button to find the example rule set.
Yeah, in general, the community is something that we really can recommend and emphasize. There's a wealth of information, and we have more than 4,000 users, actually more than 4,700 users by now. So there's a lot of exchange going on. Another question is whether we can talk a little bit more about Architect and how to use Architect and how the licensing works and how the editing and calibration process works. I'll hand over to Christian again.
Hi. The Architect functionality is also available in the eCognition developer environment. You can also create and calibrate rule sets with the Architect libraries with the developer.
And again, in the community, there are some examples. So developer also comes with the so-called quick map mode. So it's an unprotected library that you can dive into and sort of learn and experience how to actually develop Architect environments. Essentially, to make a comparison, Architect is maybe some comparable to a Visual Basic environment in which you can build your own little user interfaces, which sort of are shrink wrapped with a rule set. So you have an easy to use environment which can be defined by the rule set developer and provided to a customer who's not a rule set developer but more like a subject matter expert. So if you have different, let's say, roles in your team, you have people that are more adept in programming and remote sensing, they can build applications for Architect and you can provide these applications to image analysts who might not have the knowledge of how to use eCognition developer to develop rule sets. There was one simple question: how do we set a minimum mapping units for classes?
There's an algorithm available to use or to set a minimum mapping unit based on the area. This algorithm is called remove objects, and you can set up this process to remove all objects which are lower than a minimum area to the neighborhood object with the longest common border. It's the best way to set the minimum mapping unit for a classification task.
One question which is coming in is whether there are new algorithms to segment the LiDAR data point cloud. And if I understand correctly, it's referring to actually using the point cloud to segment data. So in a way, there are no new algorithms to actually do segmentation, but with the new functionality in creating point cloud features for image objects, you can also influence or change your segmentation. But on the other hand, you can also use a rasterized representation of the point cloud to do a segmentation. So there are essentially two different ways to utilize the point cloud in segmentation, let's say. One would be just to use the attributes generated from the point cloud in your image objects that were derived from your imagery, or you can build objects directly from the point cloud, which requires to first of all rasterize it, which is also part of eCognition. So eCognition also has algorithms that allow you to create a raster representation of your point cloud. That was something we added in the last version. There's one question whether we can give an example on, like a hands-on example on the array functionality. I think what Christian referred to in saying having adaptable, more flexible rule sets, what the array functionality allows you to do is to, for example, iterate over all classes available in a project, independently whether the project has 5 classes or 3 classes. So if you want to build or modify or let's say extend a rule set that was generated, let's say, by a colleague of yours, or you downloaded from the community, you can now apply the arrays to actually incorporate a rule set. And then let's say if you have a merging algorithm, you can say, well, merge all classes, and you don't have to know this rule set has 4 classes, but you can just say put all classes that are available into an array, and then merge all classes which are within that array. So this way you can build parts in your rule set which are independent of, let's say, the prior state of the rule set. I think that's the main advantage of that. And then you can also use it for a lot of other things like iterating over features and analyzing features or attributes.
There are also some examples available in the community to explain the power of the new array concept. It is hard to show an example how does it works, and but please download the examples from the community and follow the instruction inside the process tree, and then you will learn how you can use it and what's the power of the array concept in eCognition 8.7.
Another question we have is whether eCognition has a tuning function for support vector machine. So we have incorporated support vector machine. I know we looked into opening up attributes for support vector machine, so Christian nods his head.
Okay, in the future I hope we can insert some additional parameters like the C and the gamma value. This especially is something what we want to do in the future. Hopefully that's enough for you.
So one question is whether there are courses to learn eCognition in the United States. We do have a training department, and we frequently hold courses all across the globe, essentially. On our website, we usually have all the training courses scheduled which are upcoming. If there are no courses currently scheduled, or if there are no courses in the area that you're looking for, you can also send a request to our training group, We will also hold custom courses, depends on how many persons need to be trained. Sometimes it really makes sense to have a course at your facility. We can also work with your data on such courses, so really depends on your needs. We also are looking into offering e-learning or online learning, so we will also focus on extending our offer in that area. Another question was what level of LiDAR data was used in the given example, and I would think it's a processed data set, so it was not filtered or analyzed, if that is the question. So it's a LiDAR data which is sort of in which a point actually corresponds to the right location on the ground, but it's completely unclassified, so we're not using classification information stored in the data, but rather use the raw data, so to speak. Question is, if you're loading a LiDAR point cloud, can you actually do an extrapolation to create polygons within the eCognition environment? So meaning if you load a point cloud, can you utilize it to segment? That's what I understand. And as I said before, eCognition can go down two approaches for LiDAR analysis. One would be to segment on, for example, image data only. So if you have the combination of imagery and LiDAR, you can segment on the high resolution of the image and use the LiDAR only as an elevation information without rasterizing the LiDAR. But if you, let's say, have a LiDAR dataset only and you don't even have an image dataset, you can bring in only the LiDAR data. You can rasterize the LiDAR data within eCognition using the LiDAR conversion algorithms that we have in the software. And then you can segment the LiDAR point clouds directly in eCognition. One question is whether there will be training data available for the new version 8.7, and we can assure you there will. So we're working on training data for the new version. And also, again, the community already contains a bit of information and examples on the new functionality as well. There's one question I can hand over to Christian, who's also sorting through the questions. One question is whether it is possible to copy or move the generated card tree into the class description.
Unfortunately not, because the trained information will be stored in a string variable.
But I think we have a misunderstanding here, because the way I understand the question is whether it's possible to generate a card tree within the class description. Now I got it. Yeah, sorry. Now I was confused. So it's not possible to put the description into the class description. But since you have it in the rule set, you don't really need it in the class description. And actually in the generation, or when we discussed how to best implement card, our first approach was to directly put it into the class description. But since the class hierarchy is a hierarchical setup with, let's say, one-on-one relations in child and parent classes, it would have been very difficult to implement a card tree, because very often the same class can be within different branches of the decision tree, and this is something our class hierarchy would not support. So therefore, the implementation in the rule set is much better suited for a regression tree than actually putting it into the class hierarchy. There's a question on the support vector machine. Question is whether we use a Java lib SVM. No, that's not the case. The support vector machine is also implemented using the Open Computer Vision library. There is one question on what is the limit in gigabytes on LiDAR data which we can handle in developer. So far we have worked on fairly large LiDAR data sets, up to, let's say, 2-3 gigabyte. I realize that there are much larger LiDAR data sets around. With the eCognition 64-bit version that we are on now, it is still possible to handle very large LiDAR data sets, also using different approaches and rescaling within eCognition. This is possible, but we haven't really done a benchmark saying this is the absolute limit that we can work on. A related question would be, is there any limitation on image file size? I don't know, Christian, you might have an insight there.
I don't know something about any kind of limitations for file size.
So far we didn't really have an image which is sort of which caused any problems. Usually a limitation is in the number of image objects which you generate, and also again with the 64-bit environment, that limit is very, very high, so not an issue really. There's one question whether the new algorithm can actually calculate percentiles from the point cloud. We can do average and mode and standard deviation and min and max, but not really a percentile in those in the features, unfortunately. But this is something which I will take up, or Christian actually now noted down as an input for future versions. So that would definitely be something to look into. There's one question that I also can pass over to Christian, and the question is whether eCognition can also be used on medium or lower resolution data like Spot and Landsat, and not only in QuickBird and Iconos. And I think that's an easy question to answer.
Yes, of course. It's eCognition coming from such kind of data, and you can also classify Landsat and Spot data with it, and can use also the new machine learning algorithms based on Landsat data. It's possible, of course.
Actually, the machine learning sort of comes from that area. So most of our customers that use the CART approach are using Spot type data to do those analysis on a large scale. So we definitely also stick true to not only high resolution data. One question is whether there are any advances in understanding integrating point cloud data from a mobile platform or stationary platform, so different, let's say, projection of the point cloud data. That's a valid question, since we now have those platforms in our group, and we have teams sitting in Montreal who build those platforms. This is something that, of course, we're looking at. It's not yet part of eCognition 8.7, but I can assure you that's a topic we explore. One question is coming: how do we integrate Esri and ArcGIS? The quick answer to that is on a file basis. So most of our users are exporting the eCognition results into ArcGIS, so exporting shapefiles. So that's the easy approach. If you're looking for more closer integration, we have let's say a tool or a functionality within the eCognition server, which allows you to send data from within the eCognition server, from within the Esri ArcGIS information to be analyzed by eCognition server, and it writes back the results into Esri. But so far, the main focus of our users was actually to process data within eCognition and then export into ArcGIS. Oh, excuse me. I realized that we have much more questions than we will be able to answer in this session. Questions are still coming in. So we have recorded all the questions, the webinar. We will make sure to get back with answers on the questions that we haven't answered yet. So after the session, we'll sort through the questions. And with that, I would really like to thank everyone for spending time with us, and I hope the webinar was informative for all of you. And I also hope to be able to welcome you back to future webinars, which we will schedule. And would like to remind you, of course, to take a look into the community. If you don't have eCognition 9.7 yet, you can also download it as a trial and test it yourself. With that, I would thank you. Also to Christian, thanks a lot, and have a nice evening, everyone.